So we'll get started. So there is a ladder which is 5 meter long, is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeters per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? So how to solve this?
The ds by dt will be minus 2 centimeters per second.
Just give me a second. 1 second. There is a wall and a floor on which there is a ladder kept. Right. So this ladder's total length is 5 meters. Ladder's total length is 5 meters. The bottom of the ladder is pulled along the ground away from the wall. So when it is pulled like this, what will happen to the top surface? Is it not going to come down like this?
Yes, sir.
So when this is happening, right, one thing that is completely constant is the length of the ladder. So if I take this distance as A and this distance as B, the relation I can frame between A and B is A square plus B square is equal to 25. Accepted? So
Yes.
let me call this as 1. The bottom of the ladder is pulled along the ground away from the wall. So dB divided by dt is equal to 2 centimeters per second. How fast is its height on the wall decreasing? So dA by dt is equal to how much? When the foot of the ladder is 4 meters away from the wall. When B is equal to 4 meters. When B is equal to 4 meters, tell me what will be the value of A, guys?
3, sir.
3, sir.
3 and 3, 4, 5 are going to be Pythagorean triplets. That's right. So I hope I'm clear till this step, right? Now what we do is differentiate 1 with respect to time on both sides. What do we get? 2a into dA divided by dt plus 2b into dB divided by dt is equal to 0. Sorry. So what is the value of A and B I need to substitute? So dA by dt is equal to minus 2b times dB by dt divided by 2a. 2 and 2 are getting cancelled. Minus b divided by a into dB by dt. What is the value of b, guys? It's 4 divided by 3 into dB by dt is 2. So it is minus 8 by 3 centimeters per second. What does that minus sign indicate? Means the length is decreasing with respect to time. That's obvious, right? When the bottom, when the distance from this point along the bottom is going to increase, from the top it is going to decrease. Right? I hope it makes sense. So answer
Yes,
is
sir.
minus 8 by 3 centimeters per second. So here minus sign is very important. Right? So moving on to the next problem. So there is a particle which is moving along the curve 6y is equal to x cube plus 2. Find the position on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Interesting one. So there is a particle which is moving along the curve. 6y is equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. So how to solve this? Find the points on the curve. X comma y is equal to how much when dy by dt is equal to 8 times dx by dt. Guys, are you able to understand? So dy by dt is 8 times dx by dt. Then what is the value of x comma y? It's very simple. If I take the curve itself as equation number 1, differentiate on both sides with respect to time, then what do I get? 6 into dy by dt is equal to 3x square into dx by dt. Correct?
Yes.
So 6 into dy by dt is equal to 3x square into dx by dt. But what is dy by dt? 8 times dx by dt is equal to 3x square into dx by dt. So dx by dt is a non-zero value. You can cancel it off. 3 and 6 will get cancelled 2 times. So it is going to be 16 plus or minus term. So they are points. Don't forget that. It can be plus or minus 4. That is the reason why the question is very clear. Find the points. There is a point. Okay, you might lose half mark. Okay, be careful. Anyways, so x is equal to plus or minus 4. If I call this as 2, take 2 and substitute in 1. Tell me what are the values of y.
Sir.
1 is 11. When you put 4, you will get 11. When you put minus 4, you will get minus 31 by 3.
Yes, sir.
So x is equal to 4, y will be 11. When you put x is equal to minus 4, y will be minus 31 by 3. Because minus 64 plus 2 is minus 62 by 6. Yes. So the points are 4, 11 and minus 4, minus 31 by 3. That is the answer. Sorry, yeah. Next. So you guys try this. So the radius of an air bubble is increasing at the rate of half centimeter per second. So there is an air bubble. Generally, air bubble is considered to be in what shape?
Spherical shape.
Spherical. So an air bubble is increasing at a rate of half centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? So solution, let R be radius. Volume is equal to 4 by 3 pi r cube. So dr by dt is given as half centimeter per second. At what volume of the bubble, at what rate is the volume of the bubble increasing when r is equal to 1 centimeter? Can you guys do and tell me fast? So differentiate volume on both the sides. Is there anyone who's not understanding all these things? Do let me know.
No, sir, no doubt, sir.
Okay.
Sir, 2.
2 is the answer. Huh? Let me check. So what is dv by dt? 8 pi r square, 4 pi r square. It's actually a very good observation, you know. Whenever you differentiate volume with respect to r, you will get the area. So dv by dt is equal to 4 pi r square into dr by dt. So 4 pi into what is the value of r? 1 square into dr by dt is half. So it is going to be 2 pi. Correct? 2 pi centimeter cube per second is the answer.
So you can explain that 4 pi r square alone, sir.
Nothing, to differentiate this.
Okay, sir.
Chain rule. So 4 by 3 pi is common. Derivative of r cube is 3r square into dr by dt. 3 and 3 will get cancelled. That is like 4 pi r square.
Okay, sir. Understood.
So I have a doubt. Is it possible to get the same answer we substitute r equal to 1 in that formula, sir, 4 pi r cube?
No, you
And
should
then
not do it because see, when you're doing 4, when you're substituting r is, see, maybe if you get the answer also, no, I don't want to misguide you because that is technically wrong. It's a mathematical absurd because I'll tell you what mistake you're doing. You want to substitute this r is equal to 1 here. Am I right?
Yes, sir.
Okay, if you do that, no, what you're trying to do is v is equal to 4 by 3 into pi into 1 cube, correct?
Yes, sir.
So is this a constant value or a function or a variable?
Constant value, sir.
So constant value, when you differentiate, you're trying to misguide someone saying that dv by dt is 0. You're able to understand why it is wrong.
Yes, sir. So we can, it's wrong to do it that way.
It is wrong. After you differentiate only, you're supposed to substitute. That is why they are saying, because the volume is increasing, this r is equal to 1 is one of such instances. Because the radius is not stopping with r is equal to 1 centimeter. It will go from 1 to 1.5.
Like when it is increasing, they're asking, sir.
When it is increasing, that is the meaning. At what rate is the volume increasing when the radius is 1 centimeter? So what is the speed with which the volume is growing? That is the meaning.
Okay, sir,
because
understood.
what would have happened after the next second is the radius of the circle would have no more been 1 centimeter, rather it would have been 1.5 centimeter. That is the meaning, no? Puriyada?
Yes, I understood, sir.
Good. Okay, now try this. A balloon which always remains spherical has a variable diameter of 3 by 2 into 2x plus 1. Find the rate of change of its volume with respect to x. So here your answer can be in terms of x itself. So they are indirectly asking what is dv by dx. It's actually a simple problem. So diameter is, how much is the diameter?
3 by 2 into 2x plus 1.
So diameter is 3 by 2 into 2x plus 1. So radius will be 3 by 4 into 2x plus 1. All of that. That's it. So what is the volume? 4 by 3 pi r cube. That is 4 by 3 pi into r is 3 by 4 into 2x plus 1 the whole cube. Right? So 4 by 3, 3 by 4 will get cancelled. Pi into 2x plus 1 the whole cube is volume. So what is dv by dx? Pi into 3 into 2x plus 1 the whole square into derivative of 2x is 2. So it is going to be 6 pi into 2x plus 1 the whole square. This is the required answer. No units.
Sir, 3 by 4 will also be in the cube, right?
Oh, sorry. Sorry, I made a mistake. It should be here, right? Then 1 3 by 4 will get cancelled. Then what will you get out? You will get 9 by 16 outside, right? Are you able to understand what I did? 4 by 3 into 3 by 4 into 3 by 4 into 3 by 4. So 1 3 by 4 and 4 by 3 will get cancelled. You're left out with 9 by 16. So 9 by 16 means you will get 27 by 16. Okay, I'll write an extra step. 9 by 16 is undisturbed. You will get 3x square into this thing. This will be 8 times. So 27 by 8 times pi. 27 by 8 pi into 2x plus 1 the whole square. Can you check the answer once? (27 by 8 into pi into 2x plus 1 the whole square. Is it right?
Yes, sir, it's correct, sir.
Now try this. Sand is pouring from a pipe at a rate of 12 centimeter cube per second. Let's say the pipe is like this. Okay. From this, sand is pouring at a rate of, the volume of sand that is coming out is 12 centimeter cube per second. I found the volume because of the centimeter cube, and moreover, sand is a fluid. Right. So it is falling here. The falling sand forms a cone on the ground in such a way that the height of the cone is always, so it's forming a cone such that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand of the cone increasing? dH by dt is equal to what? When the height is 4 centimeter. How to do this?
Use lateral surface area, sir.
Why do you need to use lateral surface area? When volume, rate of change of volume is given, the volume of the sand coming out is equal to the volume of the cone that is forming. So what is the volume of the cone? 1/3 pi r square h. Correct? So the
Yes.
volume with which, the rate at which the sand is coming out is the rate at which the cone is formed, as simple as that. So dV by dt will be equal to 1/3. One issue here is, there's a good problem actually. One issue here is volume is not a function of one variable, rather it is a function of two variables, because when the cone is being formed, right, what are all the parameters that are changing? It is not a cone with a constant radius but variable height, nor a constant height with a variable base. No, both are varying simultaneously such that there is one important relation between them. What is it? H is equal to R by 6. If I take this and substitute it here, I will get 1/3 pi into, since they are asking dH by dt, it is advisable for me to write R in terms of H. Guys, you're able to understand how I'm thinking. So R in terms of H means it is 36H square into H. So what will I get? 12. It is 12 pi H cube is volume of cone. So what is dV by dt? It is 36 pi into H square into dH by dt. So, but what is dV by dt, guys? It is 12 is equal to 36 pi into, what is the value of height? 4. 4 square into dH by dt. This will get cancelled thrice. So dH by dt will be equal to 1 divided by 16 into 3 is 48. So 1 divided by 48 centimeter per second. This is the rate at which the height is increasing.
So the 36 pi h square is the differentiated product from the above formula, sir.
Oh, I didn't. It is 12H. It is 36H pi square is when you differentiate this.
Okay, sir.
Because 12 pi into derivative of H cube is 3H square into dH by dt.
I have a doubt.
Tell me.
Suppose if they don't give relation H is equal to 1/6R, what should we do, sir?
You cannot solve this problem. Question is incomplete. That's it.
Okay, sir.
Because in your syllabus you have only differentiating a function with one variable. If you have to differentiate a function with two variables, you have some other method called as partial differentiation, which you'll be learning only in engineering, if at all. But yeah, you're going to learn in engineering first.
Okay, sir.
So shall we move on to the next one? Total cost and all are not there. These problems are not there. Not there. Yeah. The rate of change of area of a circle with respect to its radius at r is equal to 6 centimeter. So area of circle is pi r square. dA divided by dr is equal to 2 pi r, which implies dA by dr is equal to, the place of r you will put 6, it is going to be 12 pi centimeter square per second. Centimeter square per centimeter. So 12 pi is the answer. It's a simple problem, right? Next. Again, total revenue is not needed. We're done with this, right? So I hope nobody has a doubt in this exercise and you're able to do it independently, right? So this is all about 6.1. So 6.1 spoke about the rate of change of quantity. Okay. The next exercise that we're going to speak about is increasing and decreasing functions. It's an interesting topic. If you guys would have observed clearly, I would have used this term increasing and decreasing function many times. Right. Where did I use it? Used in the concept of one-to-one function. You guys remember? So if a function has to be, and I used it in Rolle's theorem also, if I'm not wrong. So for you to have that Rolle's theorem valid, the function has to increase and then decrease so that you will have a value of maximum or minimum. So this exercise is going to build a base for the concept of maxima and minimum, which we call it as increasing and decreasing functions. Shall I get started? Shall we get started?
Yes, sir.
Let's take certain examples. Okay. Let's try to understand what an increasing and decreasing function means. Okay. Let's say you have a scenario where the given function to you is y is equal to x. Okay. Let's say it is y is equal to x. Then how does this graph look like? It is a graph which is a straight line passing through origin. Accepted? Similarly, if I have a question like y is equal to minus x, then the graph is something like this. Y is equal to minus x. Correct? Now look at both the graphs and tell me if you guys are able to at least guess what do we mean by increasing and decreasing functions. If suppose I give you this
Sir.
y is equal to x. Yeah, please tell me.
Sir, increasing means f of x would be greater than 0, sir.
Not
Whereas
necessary.
in decreasing means
Not necessary. F of x greater than 0 means you're trying to say that the y value should always be greater than 0.
An
But here
increase in-
you're saying f of x should be greater than 0 or f dash of x should be greater than 0?
sir, f dash of x.
Yes. That is there, but I have not yet got into technical details. Now I'm only looking into the graphs and trying to understand whether you people are able to guess which is an increasing and decreasing function. So from the basic meaning of what an increasing and decreasing means, nothing else. You need not think anything technically. Let's not get into f dash of x as of now. My question is, look at the graph and tell me which one do you think is increasing and which one do you think is decreasing? If I
Y
say
equals
increase,
X is increasing, sir.
okay, and y is equal to minus x is decreasing. That's what you're trying to say.
Yes, sir.
Okay. Okay. The next question I got in my mind is, if I have to say something is increasing or decreasing, I need to have certain references in my hand. Right. See, for example, let's say I have an inclination like this. You have gone to Phoenix Mall and you're trying to park your car. So when you try to park your car, you're going to go in the downward direction in the ramp. Right. Similarly, when
Yes.
let's say you finished the movie, you're coming out, you're going to climb up the ramp. Right. So you have some reference. If you're going in the upward direction, you're trying to say that you're trying to increase, you're trying to climb. And if you're going in the downward direction, you're saying you're going in the decline path. Or you can say you're going in a dip. Right. In a similar way, if I bring, so this is a real life situation. If I bring the same thing to a graph, if I want to analyze it mathematically, what reference do I need to take to conclude that this function is increasing? What made you think that this function is increasing?
Y value and X value increase proportionally.
Very good. That is what I expected. Means as I move from left to right, okay, whenever I talk about, see, I'll tell you one important rule, guys. Have this in your mind. Whenever you look at the word function, no, the first thing that should come in your mind is input and output. That's it. What is the input? What is the output? Here, if I take the function as y is equal to f of x, then the input is x and the output is y. So if I move from left to right along the input axis, I am going to check how the output values are going to change. That is, if I take a point x1 and x2 here, if I have to frame a relation between them, x1 and x2, what do I say? Less than, greater than, equal to?
X2 greater than X1.
X1 is less than x2, right? If I drop a perpendicular here, then this is f of x1 and this is f of x2. Now, what can I say about f of x1 and f of x2?
F of X1 less than F of X2.
Right? Means lesser the value of x1, lesser the value of y, greater the value of x2, greater the value of y, then this kind of a function, according to mathematics, is what is called as an increasing function. Okay. In a similar way, if you observe, what will happen with respect to a decreasing function? This is x1, guys. This is x2. So x1 is less than x2. By default, we can say. But what is f of x1 and f of x2? F of x1 is greater than f of x2. Means for lesser value of x, if you have a greater value of y, then that kind of a function is said to be a decreasing function. This is the first observation. Though the name of the chapter is applications of derivatives, but before that we need to understand what an increasing and decreasing function means in terms of its domain and range values. Guys, am I clear? Am I clear till this point?
Yes, sir.
Right. So that's what the book definition says. That is what they're trying to say. So the definition number 1, let I be an interval contained in the domain of the real valued function f. Then f is said to be increasing if the value of x1 is less than x2 and the value of f of x1 is less than f of x2, where x1 and x2 belong to that particular interval in which you're trying to do this analysis. Okay. Similarly, if x1 is less than x2, but f of x1 what is this? But if x1 is greater than x2, actually this is not the way they define. I don't know why they have done it. Let's forget this, guys. I'm striking it off. I'll give you a definition. If x1 is less than x2 in the interval I, and f of x1 is greater than f of x2. I hope this was clear, right? This is what we discussed in the example. If x1 is less than x2, but f of x1 is greater than f of x2, then that kind of a function is said to be a decreasing function. So you can have a function which is decreasing in a particular interval, which is increasing in a particular interval, and sometimes you can have a function which is constant in a particular interval. What will happen in the case of a constant? If x1 is less than x2, but f of x1 is equal to f of x2, actually I cannot conclude this. This is wrong. I cannot say this. I'm sorry. So constant function is nothing but f of x is equal to c, means it's having a constant value of y in a given interval. That's it. Okay, I hope I'm clear with the definition number 1.
Yes, sir.
So the question that they will ask you is, they will say, they'll give you a function. Okay, and they will ask you to apply the concept of derivatives and find the interval in which that particular function is decreasing and the interval in which the given function is increasing. See, for example, if I take sin x, if I take the graph of sin x, this is 0, this pi by 2, this pi. Correct? So if I take this interval 0 to pi, my interest of study is only between 0 to pi. Okay, between 0 to pi, I'm trying to break the intervals of x in such a way where I need to report wherever sin is increasing and where all sin is decreasing. You guys look at the graph and tell me, no. Between 0 to pi by 2, what is happening?
Increases and then decreases.
So if they ask you what is the interval in which it is increasing, it is 0 to pi by 2. The interval in which it is decreasing is pi by 2 to pi. That's it. Okay. See, that is, we look at the graph, we can tell it. But not every time it is possible for us to draw a graph style. If you have a complicated function, it will get difficult for us. So at that point, we'll be taking the help of trigonometry, derivatives. Okay. Next, this is what they have given. See. So what I wanted to say is, there are two types of increasing and decreasing that they speak about. One is called as, one they say simply increasing, and one they say it is strictly increasing. Okay, we need to understand what it is. So I'll actually, there is a mistake in this. I don't know why they have given it like this. If x1 is less than, guys, I would like to give you notes for this. Please make a note. So first, x1 less than x2. Okay. And f of x1 greater than, less than or equal to f of x2, then we call it as increasing. Please make a note. So in a given interval, if x1 and x2 are two values such that x1 is less than x2 and f of x1 is less than or equal to f of x2, then we call it as increasing. If x1 is less than x2 and f of x1 is less than f of x2, this is called as strictly increasing. This is the right way of understanding. Okay. That is how it is defined mathematically. Similarly, x1 is greater than x2, then f of x1 greater than or equal to f of x2, we can call it as, x1 less than x2. Similarly, x1 less than x2, f of x1 greater than f of x2. This will be strictly decreasing. Guys, make a note. So whenever you say strictly, you will ignore that equal to sign. If you ask me, is that equal to sign important? Yes, it is. Because the equal to will decide whether you need to put an open bracket or a closed bracket. Okay. Now I will take all these things and apply it to the graphs that are shown in the question, the textbook. See. This is a strictly increasing function. This is a strictly decreasing function. This is neither increasing nor decreasing. So this can be called as a constant function in that particular interval. Okay. So with the current knowledge that we have, let's try to solve a simple problem. Show that the function f of x is equal to 7x minus 3 is increasing on R. Okay. If x1 is less than x2, okay, if you take x1 and is less than x2 as some random interval, they are saying this whole function is increasing on the real number system itself. Let's say x1 is less than x2, then f of x1, that is 7x1 minus 3. Wait, what I will do is x1 is less than x2, right? I will show you a step-by-step procedure of how I solve. Let x1 less than x2 be a number. So what are the questions? 7x minus 3, right? So multiply with 7 on both sides. What will you get? 7x1 is less than 7x2. Subtract 3 from both sides. You will get 7x1 minus 3 is less than 7x2 minus 3. So what can you conclude, guys? This is f of x1. This is f of x2. So f of x1 is less than f of x2 for the values of x1 less than x2. So it is a strictly decreasing function.
So this is increasing, no, sir? When f of x1 is less than f of x2.
Oh, sorry, strictly increasing. Strictly increasing function. Okay. Next comes a theorem. So previously, whatever we saw was definition. Now comes a theorem. Let f be a continuous function. Function is continuous only, you can talk about its derivative. Let f be a continuous function on the interval, closed interval a to b, and differentiable on the open interval a to b. Okay. Then we can say f is an increasing function if f dash of x is greater than 0 for all values of x that belongs to the open interval a to b. Similarly, you can say f is decreasing if f dash of x is less than 0 for all values of x that belongs to a to b. And you can say f is a constant function if f dash of x is equal to 0 for all values of x which belongs to a to b. Okay. So please make a note of this, but we need to strongly think of why it is. We need to understand it. We cannot just take that as it. Make a note of this. Done?
1 minute. Done, sir.
Now see. One minute. Tell me what is the nature of the functions in both the cases. Tell me what is the nature of function, guys. Is it increasing or decreasing?
It starts from the left hand side, right? Okay.
No, it's not constant. It is an increasing function. Okay. So for this function, if I draw a tangent at any point, okay, then if I take this y is equal to f of x, then the slope of the tangent at this point is given as f dash of x. F dash of x is what actually? Slope of tangent. So if I take this angle as theta, then tan theta is slope according to straight lines. So according to differentiation, f dash of x is slope. According to straight lines, tan theta is slope. Right. So if I write f dash of x is equal to tan theta, now comes an important question. Here, is theta acute or obtuse?
Acute, sir.
Acute, sir.
Acute. So can I say this value is greater than 0 since tan theta is greater than 0 for all values of theta less than 90 degrees? Was first quadrant. So from this, can I conclude that f dash of x is 0 greater than 0? So this is the reason why we say that if you have an increasing function, then the slope of that particular graph at a given point is greater than 0. So you can ask me a question, sir, is it applicable if the increasing function is going to take with a convex structure? Yes, it is. Because this is an increasing function. This is also an increasing function because you take x1, x2, x1 is less than x2, f of x1 is greater than f of x2. So if you try to draw a tangent at any point and extend it, what will happen? It is still going to make an acute angle. And that is the reason why we say f dash of x is greater than 0 in the given interval a to b. Guys, am I clear?
Yes, sir.
Now we will go to the next concept, that is what will happen if it is decreasing? What has happened?
That's greater
F,
than
f dash of x is equal to tan theta, but it is less than 0 since theta is greater than 90 degrees. Tan theta is negative in the second quadrant, so f dash of x will be less than 0 if the function is decreasing. Clear, guys? So it is very, very, very simple that what we are supposed to do is, if they ask you to find the interval in which the given function is strictly increasing or strictly decreasing, Your work is only to differentiate it and find out where it is greater than 0 and where it is less than 0. Clear?
Yes, sir.
So let's try to do some examples and understand. So show that the function f given by this value is increasing on R. Okay. So f of x is equal to x cube minus 3x squared plus 4x. So what is f dash of x? 2x squared minus 6x plus 4. So f dash of x is greater than 0. If you are able to prove that it is for all values of R, then you can say it is strictly increasing on R. Right. So for that, what we can do is, I'll follow the textbook method as of now. So 2 into x square minus 3x plus 2 is there now. You can use a completing the square method and write it as 2 into x minus half the whole square.
It's 3 into x squared, sir.
Oh, 3x square, then it is different. Then 3 will come out, no? So 3 into x square minus 2x plus 4. So 3 into, can I write this as x minus 1 the whole square minus 1 plus 4. So 3 into x minus 1 the whole square minus 3 plus 4. So 3 into x minus 1 the whole square plus 1. If you observe, 3 into x minus 1 the whole square is always greater than 0. 1 is also always greater than 0. So this is nothing but f dash of x. Since the sum of two positive numbers is greater than 0, so whatever is the value of x you are going to substitute from the real number system, f dash of x is always greater than 0. Hence, this function is increasing on the real number R.
So shouldn't be greater than or equal to 0, sir. Since it's only increasing, not strictly increasing.
Oh, here I didn't say no that thing. For increasing, what did they say? I use that less than or equal to symbol only for this value. The definition, not for the theorem.
Okay, sir, I understand.
Sir, can you solve this sum in your method, sir?
So what I will do is 3x square minus 6x plus 4. Okay. So if I take this to be greater than 0, I will find what are all the values of x for which this is going to be greater than 0. That's it. So how can you write this?
Any negative value for x will be greater than 1.
What is the function? It is 3x square minus 6x plus 4 is greater than 0. No? So what can we write? How can we write this as? Is it possible for you to factorize 12? 12, how are you going to factorize? 1, 12, 2, 6, 3, 4. So you have nothing to factorize, right? So had it been equal to 0, then how will you write? X equal to minus b plus or minus root of b square minus 4ac. So 36 minus 4 into 36 minus 4 into 3 into 4 divided by 2. So 6 plus or minus root of, how much are we getting? 36 minus
48.
48 divided by 2. So you're getting a complex number. One minute. So had it been equal to 0, there is no real value of x for which it is going to be equal to 0.
Can we substitute any negative number, any positive number into this?
That will not work now because they told it is for the whole real number r. Wait. First of all, this formula itself is derived using the completing the square method. Actually, the book one is better because see this one, what is happening? Guys, you know how this formula has come, right? Minus b plus or minus root of b square minus 4ac. This itself is actually
Sir,
derived
it's a
using
quadratic formula.
the quadratic formula only, right? That itself came by using the completing the square method only. Okay. So that's what they have done here. 3x square minus 6x plus 4. We are trying to find the values of x for which f dash of x is greater than 0. Right? But how can you write this f dash of x? So 3 into x minus 2, sorry, x square minus 2 plus 4 greater than 0. No other option, right? You have to go only with that method. I was thinking using the quadratic formula we can solve it, but sorry, you cannot do it because they've asked us to show that it is increasing on all values of r. Or else what we should have done is we should have found the range of x values, which you will understand in subsequent problems. Okay, this is the only way. Okay, next. We'll do one last problem. So prove that the function f of x is equal to cos x is decreasing on 0 to pi. So f of x is equal to cos x. What is f dash of x? Minus sin x. So if I put minus sin x as less than 0, then I can say f dash of x is less than 0 means I'm taking the condition for decreasing. So minus sin x is less than 0 means sin x is greater than 0. So what is the interval where sin x is greater than 0?
The first quadrant.
Is it only first? It can be in the first and the second also. Sign is positive in first and second. So x belongs to 0 to pi. Means 0 to pi cos x is decreasing. So 0 to pi cos x is decreasing. Similarly, for increasing, what I will do is f of x is equal to cos x. F dash of x will be minus sin x. If I put minus sin x to be greater than 0, this is a condition for increasing. Then sin x will be less than 0. Then x belongs to pi to 2 pi. So between pi to 2 pi, I can say that the function is increasing. So between the whole interval 0 to 2 pi, what can I say? The function is neither increasing nor decreasing. Means it is neither strictly increasing nor strictly decreasing. It is increasing between 0 to pi. Sorry, decreasing between 0 to pi and increasing between pi to 2 pi. That is the meaning. Clear?
Yes, sir.
Yes, sir.
Okay. So this is how you solve. Huh? Anyways, tomorrow's class, we'll solve the problems from this exercise. Okay. So any other doubt from today's class?
So in the third subdivision given neither increasing or decreasing, that means a constant, right?
No. It is not constant. See, between the interval 0 to 2 pi, if you look at the graph of cos x, it is like this.
I'm asking generally, sir. They asked to prove.
Neither increasing nor decreasing means In some places it is decreasing, in some places it is increasing. It need not be constant. You're able to understand?
Like in tan, sir.
Like tan, see, that depends purely on interval. Right? You cannot say without interval. Tan is a completely increasing function between minus pi by 2 to pi by 2. Right? Are you able to understand?
Yes, sir.
Anyways, while we see problems tomorrow, I'll explain it. There is something
Okay.
else also I'm going to teach you. Wavy curve method. All those things I'll teach you tomorrow. Okay.
Okay, sir.
So see you all tomorrow.
Thank you.
Thank you, sir.
Thank you, sir.
Okay.